Hello, I'm Doris Esenarro, and today I'm going to talk the investigation created by me and my colleagues that is called vegetable contamination by heavy metal contained in the effluents from wastewater plant in Totora community, Ayacucho, Peru. This investigation is divided in six parts: introduction, background, methodology, data analysis, results, and conclusion. Introduction. The community of Totora is located in Ayacucho and it belongs of the district Jesus de Nazareno of the province of Huamanga. In Totora vegetables are planted, a large part of them are used treated waters, which flows into the Alameda River, whose water are also used for the irrigation of vegetables. Likewise, they use channels water of vegetables. For our research, radish, spinach, and lettuce were planted in a divided plot design in complete randomized blocks, 2F per 3E factorial design, to determine how irrigation water influences the contamination of vegetables by heavy metals such as CD, Cr, and Pb, other sources of the irrigation. We can see in the figure the Totora is located in Huamanga, Ayacucho. Background. The research of this applied type and explanatory quantitative levels as well as experimental, the instrument used were the observation and the results of the analysis of heavy metals CD, Cr, Pb determined by ECP-OES analysis. Our study zone Totora is located in the district of Jesus Nazareno. Methodology. The technique of controlled systematic observation was use of data collection, development of measurement instruments, selection of statistical tests, 2F per 3E factorial agreement, in a design of complete randomized blocks in divided plots. And DEVA model, we compared variances estimated between samples. As shown in the figure, the distribution of the plots of the vegetables under study, which were watered with two resources of water. In the figure, we can see the distribution of plots for the vegetables. Data analysis. The cadmium, chromium, and leads content in radish. It is observed that those that were irrigated with wastewater with tap water shows the cadmium content below allowed limit. The thorium content, both in those that were flooded with sewers and with tap water, is found by above the permitted limit to the lead content in both cases is allowed limit. We can see in the figure presence of CD, Cr, and Pb in rubbish, irrigated with sewage and water. Results. The results obtained from the absorption of CD, Cr, and Pb in the three types of vegetables cultivated with the effluents of PTAR, Totora, and with supply water show difference between one and other plant. As shown in the figure, for the analysis of heavy metals, the radish was harvested after 47 days, spinach after 67 days, and lettuce after 95 days, obtaining the following results. Table 1 shows the cadmium, thorium, and lead content in spinach. It is observed that the cadmium content in those that were irrigated with sewage water is higher than the allowable one and those that flood with tap water, less than allowable when the thorium content in both cases is higher than deductible, and lead content in spinach water with sewage and with tap water is less than the allowable. This content of heavy metals is vegetables. It observes that the cadmium content in the lettuce water with several water and with tap water are less than the allowable. The thorium content, both in lettuces watered with severed water and those watered with tap water, is higher than the allowable. The lead content in lettuce irrigated with wastewater is less than the permissible one, and in the lettuce irrigated with tap water is higher. Table 5 shows the analysis of variance of the lead content in the three vegetables, radish, spinach, and lettuce, watered with two resources, water, served, and pipe. It is observed that the origin species and the source species interaction do not reach statistical significance, indicating that neither the water source nor the species influence the lead content in the plant. We can see the table is the analysis of variance of lead content in three vegetables irrigated with two water sources. Discussion. Lead absorption is experimental research results are not as significant in was found that the source, the species, and the interaction source species are not significant. Therefore, there is no difference in the source of water used of irrigation of vegetables, nor is there a difference in the absorption of lead in vegetables, radish, spinach, and lettuce. Nor is there the influence of the interaction of the source used and the species. The vegetables irrigated with effluent from PTAR Totora are similar shows in some cases to those reported by other research. Those reported that in vegetables irrigated with water from Almendares River contaminated with industrial waste and provincial landfill, they obtained cadmium levels between less than 0.02 to 0.100. These values are below the PML. In the present study, the levels of cadmium in radish and lettuce are below the PML and in spinach above the PML. Conclusion. Contamination by heavy metals in vegetables irrigated with effluents from the Totora WWTP has the difference influence. The absorption of cadmium from plants irrigated with effluents as shown in the tables of the results is above the PML, as in lettuce, slightly below the PML, radish below the PML. Absorption of cadmium, such as spinach, lettuce, and radish, as shown in the result tables, these values are lower and below the PML in the three vegetables. Lead absorption of vegetables irrigated with effluent from Totora PTAR and with supply water from Totora do not differ from each other. However, the values are above the PML. It is very important to take care of the water and therefore the environment, avoid the contamination of air salts, to take care biodiversity and try to capture water from the atmosphere with the different existing techniques of sustainability. Thank you for listening.